do you see the difference between a plain function and a method call? Let me show you. I open up an editor. This is a Java editor, but let me just show you something in a plain editor here. Also, let me replicate the meeting window in, okay, so I can see you on my right bottom of my desktop, even if I switch to another program. So let me write here, just simply. Imagine a function. This is a C syntax, no? Everybody supposed to understand this, and hopefully do. Let me see. If you have something to ask, please, interrupt me anytime. So imagine this function. Imagine this function is compiled on a server. Okay? What is a function? What is a function reduced to when you compile it? Well, basically, it is a bunch of instructions at a certain memory location. And so, how am I supposed to call a function? If I have to call a function in my local computer, for example, if I have to call a function in my local computer, I can do it with most languages allow to do that. And here in this line, you see that there's the function call. Of course, you already know, I hope so, because you are you're not a bachelor student, you are master students, no? Of course, you already know that when I write f open parenthesis n closed parenthesis, this is just a syntax for something. Actually, the computer does not understand that. Hopefully, you already know that. And this function call has to be compiled some way. And what is the product of the compilation of a function call? If a function is a piece of instructions, a sequence of instruction at a certain point in memory, then a function call is a set of instruction ending with a jump to that function called position in memory. You see what I mean? Is it clear for everybody that low-level function calling means to jump, basically? Is that clear to everyone?
Yeah.
Hope so? Hope so?
Yes.
Okay. So it actually, as you might already know, it is not just about jumping. There's something else you have to do before jumping. Do any of you have an hypothesis on what I'm talking about? I mean, the jump instruction is not the whole thing. That we are missing something. The passage of parameters and picking the result. Do you know how this mechanism is achieved at the low level? Do you know that?
Yes, for a function call, we have first of all to push every parameter that we pass to the function in the stack.
Yes.
And then we have to retrieve it when we execute the function.
Exactly.
All the other variables that are in the callee function has to be stacked inside the stack. And
exactly. Bravo, Alberto. Exactly. So basically, the point is that the general translation pattern that compilers use for calling functions in a local machine, so we are still not talking about remote function calls, we are just talking about normal, plain function call. The normal way to do that is to jump to a position, but before the jump instruction, you push the relevant registers into the stack, then you jump, the function is just a piece of code that can you freely use the registers again, and at the end, before returning with the RTS extraction, you know, some assembly, no? Before the RTS instruction, before returning back, you pop the status of the registers of the callee from the stack again. And so you have a stack machine where you save the status of registers and you retrieve it back again, and this in a recursive way. And this is how functions work when you call them in a local machine. Very good. All this is absolutely useless for calling remote code, obviously. I think that you are mature enough as computer scientists, I hope so, to understand that every single bit of what I just talked to you about does not apply to remote coding. Because if you have to call another computer, it is a totally different story. It has nothing to do with pushing the stack, with jumping. It has to do with something that involves networking and synchronization. I mean, it is a total new world of complexity. You understand the difference? And let's imagine that this function, the function f, is in machine 1, and the main is in machine 2. So we are talking about some quite general scenario. We have two different computers, and one computer wants to call the function on another computer. So in this scenario, we have to make some definitions, because what does to call means? Let me explain to you. Imagine that you compile this piece of code, this one, this piece of code that I just highlighted it in blue. Imagine that you compile this piece of code on a computer. Well, probably any compiler would tell you that this F is an unbound symbol, right? Of course, because if you try to compile something that calls something else that is on another computer, there are not even symbols in there. You see what I mean? So we must first of all introduce a way for sharing symbol names between the two computers. I am talking not at the C level. I'm not talking at any language specifically. I'm talking at the general level now. So if the machine 1 defines this symbol, there must be a way to tell machine 2 that the symbol f is a function residing in machine 1. And there must be a way for machine 2 to know that the symbol f is somewhere else. You see what I mean? So there's the need to introduce a variation of the language for defining external symbols. I mean, there must be a way, for example, in C, in the C language, to tell the compiler that this F symbol is not a function that you are going to call in your local computer, but it is something alien. By alien, I mean that it resides in another memory in another computer. I give you a glimpse. Do you know this syntax in C? You never heard that?
Yes.
Yes, yes.
The extern keyword has to be followed by the function signature. And remember that in C, a function signature consists of three things: the return type, the name of the function, and the list of parameters, each one with its own type. So the signature here is int is the return type, f is the name of the function, and int is the type of the first and only argument. Extern is a keyword that in C means that this symbol does not reside in the compilation unit, but it resides somewhere else. When you call the function, like in here, the compiler emits a different piece of assembly code because the function is not local, it is external. Okay, so what does this external mean? Does this external mean on another machine? No, not yet. We are talking about external to the compilation unit, which only means that it is a symbol that can be loaded at runtime by the operating system. And the only thing that the compilers know is that it can jump to an address that has yet to be determined. But with this kind of mechanism, we are still not talking about RPC. We are still talking about just external library invocation, which is not RPC. RPC is yet another level. It is more complex. And RPC means that you have to define an external symbol with some weird syntax that the compiler doesn't even know, with some alien syntax for defining something that is outside the machine. And the RPC for C is like this, I show you. Look. You see my screen?
Yes, yes.
Yep.
Okay. This complex, well, it's not very complex, but actually it's more than a hello world. This code shows you the complexity of calling something through RPC. Calling through RPC means to do a very complex operation. So what I want you to understand today is that calling functions locally is plain simple, and it is only a jump for the CPU. Calling functions that are external to the compilation units, for example, function residing on DLLs or libraries or external modules, is still quite simple, and it is a jump on an address that has not yet been determined. Calling a function on another computer is a totally different story, and you need a lot of wrappers and a lot of code to do that. Why? Because imagine that you want to call this function f on another computer. Well, at the call site here, where you call the function f, you don't only have to jump. Can you imagine with your fantasy? Imagine what the CPU does. If you want to call a function that resides on another computer, you need to have a connection, already established connection. Send through the connection that you want to perform some function call. Then you send through the connection that you want to perform the function call for the function whose name is f, whose parameter is an integer, and whose result is an integer. And then you send the parameter. When here I write f and I apply n, I need to evaluate n and send the content of n as argument to the remote code. Are you following me? I'm picturing a scenario that is very complex. Then the server side needs a thread running constantly, listening to incoming calls, and when the thread receives a new request, it parses the request, and it says, okay, there is a client that wants to call a function f. Okay, function f is here, and the server must have the true implementation of the function in its own memory, the server. Then the client marshals the argument, the server receives the marshaled encoding of the argument, and it unmarshals it to a real value, and then the server jumps to the real implementation of the function, passing in the stack the true unmarshaled value. It picks the result, and it has to marshal the result back to the client. You see a point? So we have a server and a client, and the server and the client need to communicate through marshalling and unmarshalling. Let me write to you these new words. Perhaps you already know that. Marshal, unmarshal. There's a synonym of these two words. Marshal can also be said as serialization. To marshal means to serialize, is a synonym. And the inverse operation is unmarshal and is deserialization. Now let's have a break for 1 second. Does everybody of you know what serialization and deserialization is?
When you have an object and you have to move it to another PC, then you...
No, try to be more general, Riccardo.
Okay. When you have
a value and you want to express it in a very basic low-level format for communication. And serialization means that you have a structured value in memory, and you want to translate it into plain bits or bytes, or, for example, a string. So, for example, if you want to serialize the number 4, how could you serialize it?
In bits?
Yes, for example, or in some other way, create a way for serializing an integer. Could you serialize it? And the goal is to communicate through a socket. A socket is a connection, basically, full duplex connection, and you basically can send strings and receive strings, okay? Characters. Mm-hmm. So if you wanted to encode integers into a stream of characters like a socket is, what would you do, for example?
The stringification of the integer?
For example, exactly. For example, one common way for serializing integers is to pre-print them, basically. Yeah. And then on the other side, there's a parser that reads the integer from the string representation. So basically, if we have a value 4, one common way for serializing 4 is the 4 in ASCII. The string 4, the character 4. But if we want to serialize complex values, for example, records or lists or arrays, then we need to create and define an encoding format that must be reversible. The important part of serialization is the fact that it must be invertible. What does it mean? It means that when you serialize, you transform into characters in some format, for example, and when you deserialize, the parser must be able to understand the string format in a without ambiguities and reproduce back the original value. Let's make for a couple of examples, because this is an important point, even if you would probably never need to serialize values by hand, knowledge is very important. You need to know what we're talking about. For example, let's imagine that we have a series or an array, for example. I'm just writing stupid numbers in this way, okay? Imagine this is an array, okay? Imagine this is an array even without the semicolon. I mean, I just want to show you a series of numbers, of integers that may stay in memory, and we want to find a way for serializing an array. How would you do? How would you serialize an array?
You can do it in the plain way. So
yes,
pretty printing it.
Yes. For example,
it is correct because it is not ambiguous. I mean,
exactly, it is not ambiguous. Bravo, Riccardo. Also, you need to invent some special separator for distinguishing numbers. Otherwise, if I write 12, 23, 45, 56, 8, 10, all in a row, the parser will not be able to understand if it is this array, for example, or this array. You see what I mean?
Yeah.
You see what I mean? So there's a problem with the invertibility of the serialization. Serialization must respect some form of syntax in the translation that is not ambiguous and that can be reverted on the other side. For example, this. It is just an example, but introducing a separator between the values would allow a parser to understand where a number starts and when a number ends. Okay? Also, if you have nested arrays, imagine that you want to serialize an array of arrays, which is a data structure that is more high level. Then we need a recursive way for this serialization. Imagine that we want to serialize this with this parenthesis. I mean that the second entry of the top level array is an array of 2 elements. Okay, then you need to introduce some form of parenthesization that can support recursive parsing. You see what I mean? For example, putting brackets and the terminator inside the brackets, and so you can have recursive arrays. Are you following me? Are you understanding what I mean?
Yeah.
Okay. The important point is that any format you decide for encoding is valid as long as it is revertible and parsable on the other side. So serialization is a very complex topic. Fortunately, you do not have to do it by your hand, but because it is there are many technologies that already offer serialization, but it is a complex topic, and I want you to know that it is. So once you have the possibility to serialize and deserialize on a channel, for example, a socket, data of any type in a recursive and robust way, then RPC is possible, because you can define a protocol for telling the server which function you need by name, for example. The server looks up in the memory which function you are interested into and reads your serialized data, deserializes it, produces the real value, passes it to the function, computes the result of the function, picks the result of the function, serialize the result to the function, send it back on a socket, and the client reads the result back. Are you understanding me? So when you use RPC, you are using something complex. But we are not even talking about RPC now. RPC is more simple than the thing I'm gonna show you today. Today we are gonna study RMI. RMI is a remote method invocation, which implies that we are talking about object-oriented languages. And object-oriented languages have a whole world of complexity. They are more complex than C. For example, calling a method means to serialize not only the arguments, but also
the method name.
And also, let's make an example in Java. Now we go into Java, and I will start showing you the real RMI stuff in Java. Java supports RMI through a library and a service that I'm going to show you. And but the point is that I want you to understand what are the relevant information in a method call. Let's delete this C thing, and let's imagine a method call. A method call, we are not looking at the real code yet. Let's imagine this. Okay, let's imagine these two lines, okay? Imagine that this method would be something to be called in the remote server. Obviously, it is not the case. I'm not showing you a real remote code. I just want to invite you to understand what you're talking about. If this method call would be remote, how many informations do the client need to send to the server in order to let the server operate the calculation? How many informations are in this code? Tell me.
The remote reference of the object.
Exactly.
The remote method name.
Exactly. So with respect to RPC, in RPC, you encode the name of the function that you want to call, you serialize the arguments, you send this packet, and then you receive the result. This is the story in RPC. But in RMI, the stuff that you have to pack and to send to the server is the name of the method, the serialization of the arguments, and the serialization of the object at the left of the dot operator, right? Because you are performing the operation on a given object. So it is as if there was one more argument. Do you understand what I mean?
Yes.
You understand what I mean?
Yes.
So
Yes.
in case you have, for example, a method with 5 real arguments, you have to send 6 things. There's 5 arguments plus the object on the left side of the dot. So RMI is more complicated than RPC because there are objects involved. Also, there is another complication. What is the other complication, in your opinion? Let's see if you... I make an example. I'm trying to build really, really simple toy examples before showing you the real stuff, because the real stuff is complicated. So I want to let you understand the story at high level with very toy examples. Then we go down into real details. Imagine this. imagine I have a class animal, and the class animal has a field which is the weight of the animal, and then you have a method, and what the eat method does is to pick an argument of type animal and sum the weight of the argument to the weight of the animal. You understand this metaphor? It is a very simple metaphor for object orientation. Okay? So we have an animal class. An animal is represented only by its weight in this simple, very simple representation. And animals have only one operation, to eat. And they eat other animals. And the semantics of eating is to add the weight of the eaten animal to the weight of the animal that has eaten. Okay? Very simple. Then you have another thing. And dogs eat differently. Let's suppose that dogs do not get fatter like normal animals, but dogs get fatter by a factor of half with respect to the normal animals. I am just making a toyful example for showing you the problem of overriding. The whole object orientation paradigm relies around overriding and polymorphism. The most important thing to respect when you call methods is to respect dynamic dispatching in object orientation. So RMI must not only deal with objects, it also has to respect the polymorphism. This is the most important and complicated thing of RMI. RPC has nothing about this. RPC doesn't have subtyping, polymorphism. RPC is just calling functions with basic types. But in object-oriented languages, and RMI applies to object-oriented languages, there's a very complicated complication: polymorphism, inheritance, subtyping, and overriding. And it must work, otherwise it is useless. So let's imagine this code. Let's imagine, let me simplify. Let's make a caller. And the caller does this. Now imagine this scenario. I create a dog, an object of type dog, and I put it in a variable of type animal. This is a classic subsumption in object-oriented languages. Then I create an animal, and I put it on a variable of type animal. And then I say that the dog, U, eats the animal W. And if this has to be performed remotely, we have to send the name of the method, the argument W, the calling object U, and
the information about the dynamic type of our object.
Exactly, Alberto. And this is very subtle, no? I mean, when you think at RMI the first time, you just believe that it is the same thing of RPC with objects. But the point is that RPC is like this and RMI is like this in complexity. Because the complexity of respecting subtyping, respecting polymorphism, sending the dynamic typing, dispatching the correct method on the other side of the server, it is very complicated. Now, I lost basically more than half an hour for telling you that what we are gonna do is complicated. I don't want to discourage you. I just want you to understand and appreciate the complexity. Because the complexity of RMI makes RMI interesting to me. Because complex things are interesting. So RMI is an interesting thing because it has to respect the rules of object-oriented languages in a remote fashion. So now, let's do something real. Do you have a Java compiler in your computer? Because I'm gonna use Java for these 4 lessons because it is the simplest RMI technology around. Do you have a Java compiler in your computer? Do you have the JDK basically in your computer? Okay,
Yep.
Doesn't.
Yeah, it's fine.
Okay, for those who do not have, for example, Lorenzo Boccalone, for example, is saying that he doesn't have Java. I will link you. Well, you can find it yourself. You just write JDK on Google and you download the latest JDK. When you have the latest JDK, you can simply reproduce what I'm showing you. Just download and install it. The latest JDK is 14. It is the latest. And now I'm going to show you some real code that performs true RMI in Java. Okay, we forget about this. I deleted it. It was just a toy example. And this is actual code. So let me show you the code. First, I show you the code, and then I will show you how we use it. The program that I prepared for showing you is a program that performs one simple operation, calculating the square root of a number, of a floating point round number, remotely, okay, using Java RMI. Look, this is the client code. Okay, the code you're looking at now is the client code. And then we have a second source, which is the server code. Actually, we also have a third source file, which is an interface with no implementation. I will explain to you the meaning of this interface in a few minutes. Let's start with the client. The client is a simple but very basic program that starts from the shell and it picks one parameter from the command line and it calculates the square root of the parameter, which must be a float number. It calculates the square root on the remote server. Let me show you. I have 2 shells here. I am under Windows, so these are actually the common prompts. The 2 shells, as you can see, are on the same directory. You see, I'm on the same directory of my file system. Look, do you see, is the font enough for, okay, better?
Yeah, better.
Yeah, it's okay. Yeah.
Okay.
And also Lorenzo has a question. As I asked if it's also fine to use Python or C++ to play a little bit with remote object.
With RMI?
Yeah, a remote object, not necessarily Java, that is RMI.
No, it is not the same. First, because Python is different. And secondly, because C++ is not a reference object-based language, it's an object based on values. And so it is different. Alberto, are you talking about Lorenzo? Did I understand well?
Yeah, it was written in the chat, just to mention it.
No, it is not the same. You are free to use whatever you want, but in this course, I'm showing you Java because it is simpler. Doing the same thing in C++ is much more complicated, and I believe this thing is enough complicated for 4 lessons, even in Java. So, look, the first thing I do is to start this thing, RMI registry. What is this? This is a program that behaves like a daemon, and you have to launch it in the background, and it is basically an object broker. Do you know what an object broker is? It is a service that constantly runs on the background, and it registers all the signatures of the remote methods, classes, and interfaces that you want to use with RMI. And it is at the machine level. I mean, you launch just one process for one computer, and you keep it in the background. It is basically the process holding the dictionary of all the Java programs that want to use RMI on my computer. You understand the point? Then, once you have launched the registry, you keep it in the background. It does nothing. I mean, it does something, but you have to do nothing else. You just have to keep it on the background. Now we start the server. Do you know what the start command is in Windows? Do you know that? Do you know what the start command is? Hello?
No, but I suppose that it's only to start a program. It's just to start a program, like in this case, Java.
Yeah, it is like the. Do you know what the ampersand is on the Linux shell? Okay, it means to put in the background. Okay, so just that. So I start the Java virtual machine with the server parameter. Can you parse this command? Start is just for launching in the background. Java is the actual name of the command, and it is the Java virtual machine. And server is the actual parameter to the Java virtual machine. Okay? I start the server goes up, and I wrote a server that prints server up when he's up. So we know that it's working. The server is up. And then from another shell, I just run the Java virtual machine with a client program and a parameter. The parameter after the name after the client string, this parameter 3.5 is the first parameter that is sent to the command line to the program. And the client, as I told you before, is a program that parses the command line, picks one parameter, and sends it to the server. Look, if I don't pass any parameter from the command line, it shows me the usage. Look at the code. Here, usage prints the string that you just saw. This usage Java client float, because at the beginning, if args.lang is greater than 1, it performs the actual thing. Otherwise, it prints the usage. You understand? It is a classical console program, basically. Okay? How much familiar are you with the stuff I'm showing you? Please tell me.
Yeah,
You understand that this word, the word of shell, programs, command line, parsing the command line, how much familiar are you with this stuff?
yeah, it's pretty simple. It's fine. It's okay. At least for me.
Hope it is the same for the others.
It's fine also for me.
Okay, hope it is the same for the others. Okay, then so if I pass no argument, it tells me just the usage. But if I pass a number, look, it says minus. Sorry, I am sorry. It is my fault. It should be 7, not minus 7. The point is that I created a different example that I wanted to show you in a few minutes, but I forgot to delete it. Let me undo back to the original. I'm sorry, it's my fault. Okay. Okay, you see, I called the client with the number 49 and it replied to me 7 because it calculates the square root. Now the square root is calculated on the server, not on the client. So what the program does is to pick the argument 49, pack it somehow, send it to the server. The server receives the number, calculates the square root, and sends the result back to the client. The client picks the result, and the client then prints the result and exits. Is that clear for everyone? The trick, I mean, is the trick?
Yes.
Okay.
Yep.
Now let's have a look at the code. Let's have a look at the code. The client code is here. It is a class consisting of just a main method. And if the standard arguments are more than one, it performs the jobs. Otherwise, it prints the usage and exits. So this part, the part I just highlighted, is the core, the part that truly communicates in RMI. Let's have a look at it. This line, in line 9, I just parse the double number from the command line because the command line is a string, as you already know, and from the operating system course, you should know that command lines arguments are strings, are just strings. So I parse the number and I put it in a variable of type double, and that's pretty simple. Then the true story starts here. Inside a try-catch block, what I do is, this is the magic line. In this line, I call a method whose name is lookup inside the naming class, and well, could be like this only. This is more simple to understand. Okay? And what I'm passing here is the name of the service I want to get for RMI. What is the service? The service is an interface. So let me explain you better. The first thing a client has to do for using RMI is to ask the system. And who is the system? The system is the registry, the process that is up and holds all the information on the RMI. So the first thing that a client has to do is to ask for one name by name for one interface. So there's a binding between names and interfaces. What does it mean? It means that in the overall RMI Java system, you might register different interfaces for performing different services. In our case, we have only one service. The service is to calculate the square root of a float number. And so I created an interface and I gave it a name, square root. And inside this interface, I declared one method whose name is calculate square root. And this is my remote service. It means that if you have to perform, let's imagine, 5 different operations remotely, you can write one interface with 5 methods. In my case, I only want to perform one computation, the square root. And so I just defined one method. If I want to extend with more services, I simply can by adding another method. We will do that later. Then this is just a string constant binding, and this is the name of the service. The name of the service is preferably the name of the interface, but it is not compulsory. It is not mandatory. So basically, the client asks for the name, the string name, and it receives the interface name. I could have said, look, I delete this, and I'm sure that you will understand if I delete it. Here, this symbol does not exist anymore, of course. And in the server side, let me check where it was. Yeah. I'm sure that you understand better with the plain constants instead of pointers to plain constants. The reason why I wrote a constant is that writing a string literal in 2 programs, so in more programs, might lead to errors. You understand what I mean? So I just wrote one constant pointing to this name, but maybe you understand better in this way. So the server, when it starts, it binds itself to a name, just a string name. The client, when the client wants to communicate to the server, it looks up the given name. So there are 2 operations. The server binds, the client looks up. You see the 2 points? So the server binds the services with a given name, and the given name is public. It's just the key, it's just the name, and the client asks for that name and it receives the service. This naming.lookup method invocation gives back a result of type remote. What is remote? Remote is the super interface of the interface I defined, and I can cast it down to my own interface, and this represents my service. So the paradigm here is a bit complicated perhaps for you because it's the first time that you see it, but actually it is the most simple way you can do this. When you will understand it, you will agree with me that there are no different ways to do this except for that. So the operations that you want to perform remotely must be collected into one interface in different methods. We have only one because we only provide the computation of the square root, but if we wanted to, we could add methods. So you pack an interface with all the methods that you want to be assessed remotely. Then the server binds this interface into the memory with a name, and the clients ask for the name and receives the pointer, and you can cast it down to your interface. Now I have an object of type square root, and the square root is my interface having the method I want to call. And so in my client code here, I perform the computation. Square server dot calculate square root, passing the argument, and I get the result with the right type. As you can see, the argument has type double and the result has type double. So I don't need to serialize anything. I just call the calculate square root method as if it was a method in my local computer. You see what I mean? The old Java RMI package makes transparent, makes serialization transparent. You don't need to serialize. You just see your methods, remote methods, in the same way as normal methods. You pass arguments and you receive results. But actually, those methods internally perform very complex things. They don't just calculate the square root. They send they serialize the argument, send it to the server calculates, send back. So everything is wrapped within simple method calls that resemble the normal call of methods, but actually they are different. So the goal of RMI is to provide programmers with a simple API that resembles normal programming conventions, even if internally the things that are happening are very complex. And then I print the result. So the client code is pretty simple. Let's have a look at the server code. The server code, the server is a class, and it extends this weird superclass. What is this superclass? This superclass is provided by the Java development kit, the JDK. And the idea is this: whenever you need to do to make a server for RMI, you have to extend this special super type. Okay? Then you also have to implement the interface exposing the services that you want to perform remotely. So you see, you make a server, and the server extends this super type and implements my square root interface, which is the interface for calculating the square root. Then we have a constructor. This is a constructor. The constructor simply prints I've been constructed. This is very simple. Then here I implement the method declared by the interface. This is something that I comment now. I will decomment it later. This is an extension I'm going to show you next time. But for the time being, let me put it down so it doesn't make any confusion. Okay. So look, then there's a main method, and this is the central part. Look, the actual calculation is performed here. You see it? the actual square root calculation is performed in this line. You see that here I invoke the sqrt method in the math module. This is where I truly calculate the square root. And I calculate it from the method whose name is the name declared in the interface. That's why I say I implement the square root, because I implement the square root interface. The square root interface makes me implement this method, and I implement it directly here, and it performs the real thing. The real thing is there. So basically, the constructor does nothing. The only relevant thing to understand is this method. Then in the main, the main server does this. It creates a server object, okay? Then it binds itself to the name square root, and it says server is up, just printing in the command line, and then it gets out. And look, no, wait a second, just wait a second. I just wanted to show you. I missed the one argument. Let me show you. Let's have a look at the documentation. You see the documentation? Look, the bind or rebind method wants the name and the object of type remote that you want to bind. So I bind to the name square root, and I bind the server. Now, let's go to the shell. Let's kill the old server and recompile it. Fantastic. I recompiled it. And then no, this is not this one. From here, I can simply pull it, and it works. If I want to do something different, for example, let's say that I want to calculate the square root and multiply it by 2. For example, that's a stupid thing. I do it here, you see? This is the point where I calculate the square root. Now, for the time being, I'm not gonna complicate things a lot. The next lesson, I will show you something more complicated. As for now, I just wanted to show you this. Are you following? Are you following me, guys? Are you listening?
Yes. There is also a question from
Lorenzo Bocalon is asking, does the name refers to the server object or to the method inside the server? None. Nessuno dei due, Lorenzo. The name is just a name that you invent, but the convention is to give it the same name of the interface. But it is just a name. Just to be clear, I could have called this Pippo, okay? And then the client has to look up Pippo.
I have a trivial question about that. If you in the documentation, it's written that the name has to be an URL, and in this case, we are passing a simple name.
Excuse me. In the documentation,
it's written that we have to pass an URL.
A URL, yes. It is a new way of doing that, but I am using the most basic version. A string, a simple string, is like a simple URL. You see
Yeah,
what I
so
mean?
it's basically binding to the localhost.
Exactly. They extended and they generalized the whole thing to URLs in order to have some hierarchy inside names, no? Because names, URLs are like names with a hierarchy, with like packages, for example, or like directories, no? But basically they are strings. And if you say, I register a server with the name Pippo, the client must look up the name Pippo. This is the point. Did you find the documentation, Alberto?
Yeah, it's only written that we have to use an URL, and yeah, for me it was a little bit surprising that passing only a name,
Yes.
the client knows that is binded to localhost. It's not so straightforward.
Exactly. It was surprising to me as well. The point is that
it's only a matter of choice, but yeah,
it's only a matter of choice, exactly. And imagine that the service, the name could be a longer name, a URL, because you are asking for a name that is on a remote machine. For example, you can provide a full URL with an IP, a port, a slash, and something else, okay? So in my case, in my example, I wrote Pippo just because I am in localhost, and automatically it is as if I wrote localhost : Pippo. You say what I mean? But if I wanted to do it in a different computer, I needed to put the IP address or at least the DNS name, okay?
Yeah, of course. It was only for pointing out that.
Yeah. It would be interesting, Alberto, to make some experiments, and you could bring up the server on your computer, and if you have an open port on your firewall, but we have to discover which port RMI is using, and also if you can open for incoming connections the port, we can perform true RMI between me and you. You see what I mean?
Yeah. I can try to bring up a server, but I don't think we don't have.
Maybe for the next time, not today, because today we are almost done. At 6 o'clock we are done. But maybe for the next time, for next Wednesday, we can make some experiment.
Yeah, we can also use some Azure machine if everybody wants. So
exactly. And the naming class in Java is basically a class full of well, not really full. It is only 5 methods. They are all static methods, as you see, and they are basically the methods for interacting with the registry. What is the registry? The registry is the daemon process that I showed you at the beginning, the one that runs in the background. When a server binds the service with a name, it simply connects to the registry, and it says to the registry, okay, hello registry, I want to register this interface with the name Pippo. And the registry says, okay. And when the client calls the lookup method, what it does is this: the client calls the registry server and say, hello registry, I want to look up with the name Pippo. Is there anything bound to the name Pippo? And the registry says, yes, there's this bound to the name Pippo. And it sends to me my interface. And then you see there are also other methods. List, for example, returns an array of strings, and it simply returns the list of available services. And rebind allows you to bind a service to a name that is already occupied, that is already busy. And unbind allows the programmer to delete the binding. Okay, so you can bind, rebind, and unbind. Everything is collected in this naming class in Java. It is a very I don't know if you agree with me, but I believe it is a very simple API. It is hard to do in a simpler way, because what can you do less than this? I mean, when you want to expose a service, you bind it to a name. When you want to use a service, you look up the name, and then you can delete it or rebind it or have a list of all the available services. I mean, this is an example of a very essential API and very well designed. It is pretty clear what it does. Don't know if you agree with me. And back to the code. When we want to exploit the advanced features of an object-oriented language, we can do even more than this. Look at this class. I don't know if you know Java very well, but maybe you know other object-oriented languages, and it is the same. If you want me to explain to you the language, you just tell me what language you are familiar with, and since I know almost all languages, I can translate the thing to you, to your familiar language. If you don't understand it, don't worry. But basically, what I'm showing you here is a class neg server that extends server. And what is server? Server is this. And so it is a second class. It is not on a separate file just because I didn't want to define a separate file. I just put it as a nested class, but it is a static nested class, so it is completely unrelated to its enclosing parent. I could have put it on a different file. It is just here for being easier to read, just for that. Don't make confusion. So it is a subclass of the server class. And look, it redefines the calculate square root method with the calculation of the square root negated. You see? The minus math squared. Why am I showing you this? Because object orientation allows for a number of interesting exploits in RMI. With object orientation, you can use polymorphism and inheritance to make services perform different tasks, even without the client knowing it. Look. If I change my server with only this, that is constructing the subclass instead of the superclass, I instantiate the subclass, I bind it to the very same name, people. Look at what happens. Of course, I need to compile it before. Let me kill the original server. Let me compile. Now look at the what it wrote. It says constructor server, constructor neg server. Why? Do you understand why? Are you able to understand why? Look at the code here.
Yes, because first of all, it calls the superclass, the constructor superclass, and then it calls his constructor.
Bravissimo, exactly. Because when you create a subclass, you call the constructor first calls the constructor of the superclass, and then the constructor of the subclass. So the order of the prints is server first and neg server second, and it simply proves that we are constructing a different class here. And afterwards, I can pick my client, and look, it brings a negated result. So it means that the client knows nothing about this. I just called a service that has the same name, the same interface, the same signature, the same result type. Everything is the same as before. But in the server side, I am constructing a subclass, and the subclass has an override of the behavior of the method. So this is the demonstration that dynamic dispatching works on the server side, because even if I subsume the next server to the square root interface, the true actual implementation is correctly called, and this is the method code, not this one. It's correct. Do you remember the example before for the dog and the animal that I made half an hour ago? The point was, if I create a dog and I put the dog into a variable of type animal, and then I call the eat method on the animal, does it dispatch the eat implementation that the dog subclass redefined? Yes, it does, even remotely, because it reproduces the dynamic dispatching technique that Java and other object-oriented languages perform locally. So RMI is not only remote method invocation, it's also remote dynamic dispatching. And this allows for object-oriented programs to work remotely in a seamless way, because I can simply use subtyping, inheritance, overriding, or whatever on the server side, and the client doesn't know that. It simply calls the stuff as usual, and the things work even if it is on the server side. A few minutes for a few questions. I would finish here for today, and just if you have questions.
Yeah, Professor.
Of course. Tell me, Ricardo.
Can you please put the code on the Moodle, or can you please
The
send
code
us?
is already committed. There's a repository. I show you.
Okay.
There's a repository, and the repository is in my personal GitHub profile. The name of the repository is Lab Cloud.
Okay.
You see it?
Yeah. Thank you, Professor. Found.
You can clone it, and well, I think that you are already used to GitHub, no?
Yeah.
You don't need to, okay.
Thank you.
So anybody else interested in having the code and to play around with it can go to this URL. I will give you the URL.
Professor, if you want, I can put the URL.
Let me do that.
Okay.
I verify with that. In the chat, I put the URL of the repository for this course. Lorenzo Boccalon is asking a few questions. Does the name refer to the server object or the method inside the server? The name is totally unrelated. It is just a name. Then, does naming establish connection with the remote server if the URL is not localhost? No, naming is just a class. You mean the bind method, Lorenzo? Then are registry and the broker the same thing? Almost. Object brokers are a generalization of this thing that Java calls a registry. Object brokers are like Corba. You know Corba? Never heard? Or they are basically huge technologies developed 20 years ago that they are less common today, but they are basically servers that have a heap memory with objects in them, and you can deploy objects in this remote server memory if you want, and call it retrieving by serialization. Registry is just a name that the authors of the Java language gave to their broker, basically. So the actual name is broker, but Java call it registry. If we don't have any other questions, we stop here for today. I will publish the lesson in my YouTube account. I will give you the URL of my YouTube account the next time, okay? Or I tell Simonetta to, or I can give it even now if you want. If you have a second, I go into my account on YouTube and I will give you the URL of my YouTube account. I have a special YouTube channel only for no, it is not this. It is a special channel for lessons and for the university. It is not my personal channel. It is my professional channel. Here you go. Here is this is the YouTube channel, and here you will find, of course, as you can see, there's a lot of other videos because there are also the videos of my other courses. I am doing a lot in these days. I will add a section whose name will be Lab Cloud Computing or something like that, and I will put the video here. Okay. Yeah. So, guys, thank you for your attention. And see you on Wednesday, the 25. That is next Wednesday, basically. Next Wednesday at the 4:30, like today. Okay.
Yep. Okay. Thank you very much.
Goodbye. Goodbye.
Thank you.
Goodbye.